Hello everyone. In this video, we are going to learn about Newton's laws of motion. Newton has proposed total three laws. Okay. In those three laws, let us first discuss about the first law of motion. Newton's first law of motion. Okay. So Newton's first law of motion says that a particle remains at rest or moves in a straight line with a constant speed unless it is compelled to change the state by an external unbalanced force. So what does it mean? So here Newton's first law is going to tell us that suppose let us imagine that I have placed a book on a table. Okay, fine. This is one situation. And the second situation is I have turned on a fan. Okay, just imagine that now the fan is rotating. This is situation 2. Now you tell me, is it possible for the book to change its position by itself? It is not possible. Is it possible for the fan to get stopped by its own? It is also not possible. So when it is possible when I take the book from the table. And in the second situation, it is possible when I turn off the fan or when I switch off the fan. So what is happening here when I take the book? It means when I apply the external force. So when I apply the external force, then the position of the book, which is at rest, will come into motion. Understood my point? Secondly, when I apply the force to switch off the fan, it is nothing but I am applying an external force. Then fan gets stopped. So this is called as this is what we study in Newton's first law. So Newton's first law says that every object in the universe, every object which is at rest or in motion will not change its state until and unless an external force act on it. So that is called Newton's first law. So Newton's first law says that every object in the universe will remain at rest. So this book will remain at rest till what time? Until and unless I apply the external force, until and unless I will not take the book away from the table or from the table. And the fan remain in motion until and unless I switch off the fan, either power has to go or switch off the fan. So these are the two conditions. So till that time, both the bodies will be remain, one will remain at rest, another will remain in motion. So this is called Newton's first law of motion. Okay, so until and unless we do not apply external force, the body will remain in its state. This is what Newton's first law tells us. And here we study about inertia and mass. So what is inertia? So actually inertia is nothing but inertia describe the state of the body. Suppose here if you take a body which is 10 kilograms, okay, and let us consider another body which is of 1 kg. Now tell me, if I apply 5 Newton force on 10 kg and 5 Newton force on 1 kg, I am applying same force on two bodies. Which body will move more distance or which body will move with more speed? It is 1 kg. Why? Because see, before I apply the force, both the bodies, 1 kg body, 10 kg body, both are in rest position. So when I apply the force, 5 Newton, same force, we observe that the 1 kg body moves with greater speed than 10 kg, because the reason is here the 10 kg the body has more mass. So more mass more inertia. Inertia is nothing but a position or a state of the body. So what is the state of the body? It is at rest. So when body is having more mass, it tries to keep itself at rest only because it has more mass. So what is, so more mass, more inertia. Inertia is nothing but a state. It's a position, a state of the body. And here less mass. So less mass, less inertia. Clear? Next. Second one is inertia of rest. Okay. Second one, next one is inertia of rest. So inertia of rest says that tendency of a body to continued state of rest. So what is it saying? As I explained in the first example, that when a body is kept on the table, the body will be continuously in the state of rest only. Yes or no? So this example. So why it is at rest? Because the state is at rest. So the body try to keep on rest only. So this is called inertia of rest. Now what about inertia of motion? So this example you can take. So inertia of motion is nothing but the state of the body which continue in the state of motion only. That is called inertia of motion. So inertia of mass, inertia of rest, inertia of motion, that we study in first law of motion. Now let us come to Newton's second law of motion. Before going to tell you Newton's second law of motion, I would like to explain two examples. Suppose, imagine that here, this is a truck which is at rest position. Now truck is in rest position, okay? So it means velocity equals to 0. Okay, and the direction is same. One more truck, okay, one more truck. Here now it is in motion. It is in motion, and velocity, just let us that velocity is suppose 10 or 100 meter per second, and the direction also same. Now what do you observe in these two cases? Here one body is in rest whose velocity is 0, and another case the body, one body is in motion whose velocity is constant in the same direction. So here what do you observe? One is called, one is at rest, one is at motion. So is there any change in velocity? In this case, no change in velocity. Time is, suppose in the morning at 9 a.m., just let us imagine at 9 a.m., the body is in rest position. Even at 10 o'clock also, the body will remain at rest. So there is no change in velocity because velocity is 0 at 9 a.m., velocity is 0 at 10 a.m. as well. Now in this case, 9 a.m., just let us imagine the body is going, the bus or truck is going with a speed of 100 meter per second. Even at 10 o'clock also, the body is going in the same speed at the same direction. So there is no change in velocity, constant. We can say there is a constant velocity. Understood? So here, suppose suddenly after some time, if velocity changes to 150 meter per second, understood? Velocity change to 1 meter per 150. Previously it is 100, now 150. So here what did we observe? We observed that velocity is changed. So this is called rate of change of velocity. So rate of change of velocity, we call it as acceleration. Clear? Okay, I try to explain with an example. Acceleration. So acceleration nothing but rate of change of velocity. Now this acceleration again depends on two factors. One is, see, acceleration. Suppose if you want to increase the velocity to 200 meter per second. So what you need to do? You need to apply force on it. Understood? Now, okay. Again, two points that you remember. Suppose, imagine that I have a block whose mass is 100 kilogram. Okay. It is here. And again I have another block whose mass is 500 kg. Clear? Now what I do, I'll apply 50 Newton force on 100 kg and 50 Newton force on 500 kg. Now tell me which body will have more acceleration, which body will move with more speed. Here force is same. Then which body will move with more speed? First one. Why? Because it has less mass. So now acceleration again depends on mass. It is here reverse. So acceleration less mass. Force, if acceleration increases, force also increases. But here in this case, acceleration is opposite to the mass. If mass is more, acceleration is less. If mass is less, acceleration will be more. Understood? So what can we write? Finally, what can we write finally? We can write in this way. So I'll write acceleration is equals to force by mass. It means acceleration is directly proportional to force, and then acceleration is inversely proportional to mass. Understood? So if you did not understand, so what is the meaning? Direct. This symbol is called directly proportionality. We use in mathematics also. So directly proportionality means what? Whatever changes happens in left side, same changes will happen in the right side also. If you increase acceleration, automatically force also increases. So that is the reason I have written acceleration is directly proportional to force. If acceleration increases, force increases. Or if force increases, acceleration increases. And what about acceleration and mass? If acceleration, if mass is more, acceleration will be less. Understood? If mass is less, acceleration will be more. So they are opposite to each other. So that is the reason we write it as acceleration is inversely proportional to mass. So finally we can write in this way that acceleration is equals to force by mass, or simply we can also write it as force is equals to mass into acceleration. Clear? Okay, fine. So Newton's second law says that, tells us about acceleration. So acceleration is directly proportional to net force and acceleration is inversely proportional to mass. So what will be the unit of this force? Tell me. We know that SI unit of mass is kilogram and SI unit of acceleration is meter per second square. As we have already studied in the previous topic, we can also write it as 1 Newton. So 1 Newton is equals to, we can write in this 1 kg into 1 meter per second square, or you can simply write 1 Newton is equals to 1 kg into meter per second square. So this is the SI unit of force. So SI unit of force will be kg into meter per second square, or simply you may write, you can also write Newton. Okay, so fine. Now again in Newton's second law, as we have studied about inertia and mass in the first law, and inertia of rest, inertia of motion. Now in second law of motion, we study about linear momentum. Linear momentum. So one thing you should remember, momentum is nothing but it's a speed. Simply, to say simply, it is a speed. So linear momentum is denoted with letter P. Okay, so we can say that the linear momentum, the total quantity of motion contained in a body, is known as its momentum. So total quantity means of the amount of speed or motion contained in a body is known as its momentum. Suppose if a bus is going with 50 km per hour, so if I ask you what is the momentum of the bus, what is the velocity of the bus, then you will say that, sir, yes, it is 50 km per hour. So that is the total speed present in the bus. So that's called momentum. So total quantity of motion contained in the body is known as momentum. It is a vector quantity. So momentum is denoted with letter P, and momentum is nothing but, the formula is mass into velocity. So what will be the SI unit? Kg into meter per second. SI unit is kg into meter per second. Now, the next topic is about impulse. So, impulse nothing but the product of force into time. Impulse is equals to the product of force and time. Is known as impulse. So, we can also say that when a large force acts on a body for a very short duration of time. See here, it means that large force acting on a body in a very short duration of time, then this large force is called impulsive force. So here what happened? What does it mean? In very less time, force is more. So that is called as impulsive force. So as I have written, impulse, the formula I is equals to force into time, F into T. So what is the force formula? Mass into acceleration. And I'll write T as well. Now, what is the formula of acceleration? We have already discussed. A is equals to final velocity minus initial velocity by time taken, v minus u by t. So, in place of A, I'll write m into v minus u by t into t. So, here tt get cancelled. So, impulse force we can write m is equals to, sorry, I is equals to m into v minus u. Clear? Okay, fine. Now, hence, impulse is defined as change in momentum. So, here what has happened? Change in momentum. So, the area under force versus time graph will change in momentum called there is impulse. So, it's a vector quantity. The extent of impulse is Newton into second. So, why Newton into second? Because impulse formula force into time. So, what is the SI unit of force? Newton, and SI unit of time is second. So, impulse SI unit is equals to Newton into second. Now, what about the next one? Next is about Newton's third law. So, Newton's third law says that for every action, there is equal and opposite reaction. Imagine that you are playing with a ball. Okay, a boy is playing with a ball, and this boy throw a ball on the wall with force 10 newtons. So what happens if the boy throws a ball towards the wall? The ball will go and hit the wall, and again it will come back. So with how much speed it comes back again? It will come with 10 newtons. So the amount of force which you apply on the ball, when it hit the ball, again it will come with the same speed or opposite in the opposite direction. So that is called Newton's third law experiment. So that is the reason the Newton third law, the concept we use in rocket flying. The gas which spells out from the rocket gives the opposite force to move the rocket in a greater speed. Clear? So Newton's third law says that for every action there is equal and opposite reaction. So this is about Newton's third law of motion. Okay. So there are numericals also on this topic. So that we will study. So next one is pressure. So pressure is nothing but the force acting on unit area. Pressure is equals to force acting on unit area. Okay. So pressure depends on two factors. And this is the force acting per unit area is called as pressure, and pressure formula P is equals to F by A. So F SI unit is Newton, and area we measure in meter square. So this is the SI unit of pressure. R, you can also write it as Pascal. PACL is the scientist name. So if I am writing scientist name, I write full name. If just letter here, I write PA. Okay, there are other rules also. Okay, so why we are writing PA, that we'll discuss in the some other topic. So Pascal is a scientist. In honor of French physicist Blaise Pascal. So that is the reason we write. The unit of pressure is Pascal. Okay, so pressure again depends on the effect of force. It acts of it depends on two factors. One is amount of force applied, the amount of force which you apply, and then area of contact over the force is applied. See, pressure depends on two factors. One is the amount of force which you are applying, and pressure at the area of contact. Suppose, imagine that I'm trying to hammer a nail to the wall. So which side will I use? Will I use the sharp edge or the blunt side? I'll use the sharp side, because when I apply pressure or force on this blunt side where area is more, and the nail which is having a narrow area or the less area, it will easily get into the wall. So here when we apply less pressure, as area of contact is very less, so pressure will be more. Pressure acts on it more, so it will deep inside get into the wall. Okay, that is the reason even knives, blades, axes have sharp and thin at the cutting edge to decrease the area of intersection. So sharp edge, the knives will have a sharp edge because the area of contact is very less. So it will easily cut the vegetables or any other things, even by applying with a less pressure on it. Okay. Similarly, saying that, do you know the walls of a dams are specially thickened in a border at the base. So he's saying that, suppose if you have seen the bridges when you travel by train or bus, you will observe that in the bridges they are constructed in this way. The upper part is very narrow size, and here the lower part, which is inside the water, will be in a wider shape because they are under the water. So what happens, sir? Why they are wider, so widely made? Because the deeper inside, pressure will be more. Okay, so water pressure will be more and in the depth. So that is the reason the swimmers, when they go get into the deeper level of the ocean or seas, they use they wear a special suit. Why? Because the pressure will be more to protect themselves from the pressure. Otherwise, what will happen? Otherwise, due to the unbalanced pressure, or due to the more pressure in the water at the depth, the body may burst and the person may die as well. So this is all about pressure concept. So in the next concept, we will discuss about atmospheric pressure, and then pressure exerted by liquids, and Archimedes principle, flotation, applications of pressure. So with this, we can conclude this chapter. So one more video I'll make where I can complete this chapter. Okay, is it okay? Understood? I hope you all have understood. So any doubts if you have, you can put it in the mention in the comment box. Thank you so much.